Hello again. This will be the fourth video in a series of videos about the ACT prep that I've been doing during the coronavirus outbreak. This is a good spot to just kind of go over some quick test taking strategies for ACT math, so just to remind ourselves of them. These are things you should have hopefully heard before. It's 60 questions in 60 minutes, and it partially depends on you and what score you might already have and where you're trying to get. But for a lot of my students, I try to encourage them to stop thinking of it that way. 60 questions, 60 minutes is very overwhelming for a lot of them. And they're just trying to get to an average to slightly above average score. And to do that, you only need to get around half the questions right. And while it's not perfectly that each problem gets a little bit harder, it is generally the case that as you flip the pages, each page on the whole is a little harder than the page before it. And so you really want to spend most of your time on the first 30 or 40 questions, because the last 20 or so, you're going to guess on a lot of those anyway. And so I just really encourage my students to spend about 50 minutes on the first 40 trying to find hopefully 20 to 25 you feel really good about, and be sure you've done a good job on those. And then hoping that guessing on the rest in that last 5 or 10 minutes, the same choice all the way down through, is enough to get you to a good starting score. For some people, that's the goal. Their goal is just get into community college, or they're okay if their math score is their lowest score. So these really aren't, that's not necessarily advice for a person that is already at a 25 and trying to get into the higher 20s. The other thing to think about if you're more in that position is to get better at reading a question and immediately marking it one of three ways. If you know how to do it, you just go ahead and do it, answer it. If you read it and you're like, I'm pretty sure I can do this, but it's going to take me more than a minute or a minute and a half, I encourage students to star those, and then you come back to it after you've tried everything else. And then if it's one that you're really not sure about, you either go ahead and guess or put a question mark and then come back to it later. So with that sort of overview of strategy, I'm going to put the magic little reflector doohickey on. And flip the view, and we're going to be starting at 31. So we're moving into the second half of the test, where a lot of you are going to feel like you don't know how to do more of the questions than you do know how to do. 31. The number 1001 is the product of the prime numbers 7, 11, and 13. So they're saying that 1001 is 7 times 11 times 13. Knowing this, what is the prime factorization of 30,030? So they're hoping that if you're an optimist, they're hoping that you notice that this is just 30 times 1001. Or if you're a pessimist, they're counting on you not noticing that. We already have that 1001 is 7 times 11 times 13. 30 is 2 times 15, which is 3 times 5. So we need a 2, a 3, a 5, a 7, an 11, and a 13, which is choice E. Somewhere around halfway through the test, you'll hit your first one of these. There's going to be these, I call them multi-part questions. There's always a box at the beginning that tells you which questions are going to use the same information that's immediately after that box. And it's kind of hard to notice it on this one because it's at the bottom of the page. There's always a horizontal line to end that section. So from here to there is one multi-part question. You're going to read this information quickly and then answer this question. And then when you go to the question below it, you're going to go back up to this information again. And sometimes they might add in extra information down here that you didn't need for this question. A lot of what they're trying to do here is honestly get you to forget things from the top to the bottom, like you maybe are 3 or 4 questions in and you realize that you don't remember and you have to go reread, or you even forget that maybe it was a multi-part question and mess up. So let's get started. Makia, an intern with the Parks and Recreation Department, is developing a proposal for the new trapezoidal Springdale Park. The figure below shows a scale drawing of the proposed park with 3 side lengths and the radius of the merry-go-round given in inches. In Makia's drawing, 1 inch represents 1.5 feet. So again, if I were able to do this in the book, I would be marking this up as best I can, but I'm trying to not write in the book so that if I mess up, because I don't have easy access to a second book right now. You want to try to decide which of the things from this multi-part problem are going to end up mattering. And so if you quickly skim back through this, the only thing that matters maybe in this first couple of sentences is that this is a trapezoid, which is kind of implied by the drawing, but it's not directly in the drawing. And it does mention that this is 4 inches. 4 inches, but these are already inches. So that naked number right there that doesn't have any units is probably supposed to be inches as well if you had to guess. What really matters, and you'll need it for at least one of these problems somewhere, is that the 1 inch is going to represent 1.5 feet. So we'll probably need that. 32. What is the area in square inches of the scale drawing of the park? So a right trapezoid like we have here on number 32, I'm just going to split into a rectangle and a triangle. This is 40 inches. This is 28 inches. This is 16 inches. Because I've split it into a rectangle and a triangle, this is also 16 inches. Because the bottom is 40, but the top is 28, and these are right angles, I know that from there to there is just 40 subtract 28, which would be 12. So that's 12 inches. So really I want to do this problem in 2 parts. I've got a triangle that's 12 by 16, and I've got a rectangle that's 16 by 28. And we know to multiply here, so that I could do without a calculator, but I've already gone a little long doing the intro, so it's 448 off the calculator. And then remember that this would be half of a rectangle, so it's 1/2 of these 2 numbers, or I multiply them and then divide by 2, whichever of those you're more used to. Like here you might be used to the formula 1/2 base times height. Here you might be used to base times height or length times width. A lot of these basic formulas you're going to want to have memorized, but it's better if you understand them. This ends up being 96. If you understand them, then you don't have to really memorize as much. They wanted, according to the question, the area of the scale drawing. So we really are not looking to convert. If we needed to convert these, we would have converted them first before we ever did any of the multiplications. When you need to convert units, usually it's easier to convert them. 448 plus 96 is going to be just under 550. When I look at the choices, G is the only one that is just under 550. So I'm not going to actually bother to add them together. I'm just going to look at the choices and say, hey, that's the only one that makes sense. 33. McKay's proposal includes installing a fence on the perimeter of the park. What is perimeter in feet of the park? So here we want the same shape, but we want perimeter for 33. But we want it in feet. So now we are going to do our conversions. This was going to be 16, but according to the prompt all the way back up here at the top, 1 inch is 1.5 feet. So whatever number we have, we can cross it off and multiply it by 1.5. Half of 16 is 8. 16 plus 8 is 24. So this is 24 feet. This was going to be 28, but half of 28 is 14. 14 and 28, 10 is 38, 42 feet. This was going to be 40 inches. Half of 40 is 20, so that gets us to 60 feet. So we know we're going to add these three up plus this. Let's go ahead and see where we're at. 60 and 40 is 100, 102, 126. 126 plus a bit. Well, look at the answer choices. We're already at 126, and we need to add a little more. So you might have been tempted to do Pythagorean theorem here and try to sort this out. But with some test-taking strategy, we already know it has to be E 156. All the answers are just too small. 34. The length of the south side of the park is what percent of the length of the north side? They want, on 34, south side to north as a percent. And the south side is the longer side. So it's 40 out of, not 40, yeah, 40, we're going to do the inches. 40 out of 28. So that's over 100%. All these answers are more than 100%. Now, it's not over 200% because 28 doubled would be more than 40. So I know it's not that one. If we go to the calculator and we hit 40 divided by 28, you see that it's about 142%. And only one of the choices is anywhere close to that. Remember, with the percent, it's per 100. It's 2 decimal places. So it's 142 and some more. It's got to be H. In this particular practice ACT, they immediately now follow this up with another multi-part problem based on a schematic. And this time it's going to be about like blueprints for a house. The Smith family is planning to build a 3-room cabin which consists of 2 bedrooms, BR and LR. Sorry, bedrooms are BR, and LR is the living room. Almost got me. Shown below are the rectangular floor plan, left figure. So far, I don't see anything there that I have to remember or need. And a side view of the cabin, right figure. In the side view, the roof forms an isosceles triangle. That's kind of implied by these 30-degree angles. The walls are perpendicular to the level floor. Okay, that's just a good assumption that it's not falling over. AC is parallel to ED. Yeah, we expect the ceiling to be parallel to the floor. F is the midpoint of AC. It looks like it's the midpoint, but it's nice to know. And BF is perpendicular to AC. Okay, so really there's nothing in here that we have to have. We can just ignore these words, I think, for the rest of the problem. We can just focus on these diagrams. Then they throw in, during the week, the Smiths plan to roof the cabin. There is a 20% chance of rain each day. I have a feeling we'll only need that for one of the problems, so we don't want to forget that that's there. But we won't need it for every problem. 35. Mr. Smith plans to build a 3-foot walkway around the outside of the cabin as shown in the floor plan. Okay, so the okay, so that's 3 feet, and that's 3 feet, and then it's 30 from there to there, which is why it's 36 total here. This is 24, but that's 3 feet, and that's 3 feet. That's why they're labeling it 24 there, but 30 here. Okay, I think I got it. What will be the area in square feet of the top surface of the walkway? So really they want to know what the surface area of this light gray shading is going to be. You could do this a couple different ways, but honestly the easiest way is to probably think of it as one rectangle inside of another. And the big rectangle minus the small rectangle in terms of area is what we're shooting for. So the big dimensions are 36 by 30. And the smaller dimensions are 30 by 24. And you could get both of these numbers on a calculator and then subtract them. There's other things you could have done on this problem. I'm going to be brave and key it all at once. So that's 360 square feet, which is choice C. 36. Ms. Smith will install a ceiling fan in each room of the cabin and will place curtains over the 4 windows. The windows are in here, this little rectangle on the wall. I only know that because of prior experience with blueprints. And then this, that's a door. That's what they're showing there. Each of the ceiling fans has a price of $52. So let's see. Ceiling fan is $52. They're going to go in each room. So there are 2 bedrooms and a living room, so that's times 3. The price of the curtains for each small window is $39.50. So small window, $39.50 for curtains. The large window is twice that. Based on this information, which of the following values is closest to the total price Ms. Smith will pay for curtains and ceiling fans? So 52 times 3, well, 3 times 50 would be 150, but 3 times 2 is 6. So it's 156 for the ceiling fans. And I'm going to just cheat and basically take this problem and look at it again carefully, and I see that there are 3 small windows. There's only the 1 large window, but it's basically a double of a small window. So really, I want $39.50 times 5. 3 small windows, and then the large window double counts. $39.50 times 5 is $197.50. So I'm adding about $200 to this. I go look at the choices. $200, so $356, but a little less than that. Which of the following is closest? Well, only one choice, $354, is in that vicinity. So I estimated that to 200 and looked at the choices and got that it was J, 354. 37. Mr. and Mrs. Smith plan to roof the cabin on 2 consecutive days. Assuming the chance of rain is independent of the day, what is the probability that it will rain both days? So it's 20%. Like, look how long they gave you to forget this was over here. It's 20% chance of rain. So what's the probability that it will rain both days? So rain 2 days in a row would be the 20% times the 20%, or 0.2 times 0.2. 2 times 2 is 4, but it needs 2 decimal places. So really, there's only a 4% chance that it'll rain both days, which is choice A. Which of the following expressions, when evaluated, is an irrational number? And then I notice that there's all kinds of square roots involved. So there's nothing we can really do here except start trying these. Oh, I take that back. There is a shortcut. Because square root of 2 and square root of 8 are both irrational. If you add them together, it's going to stay irrational. So it ends up being choice K. But I think I only see that because I'm a high school math teacher. I think most of you would sit here and start trying them to see what happens with each one. For the first choice, that would be the square root of 2/8, which reduces to 1/4. And then the square root of 1 is 1, but the square root of 4 is 2. So that simplifies to 1/2. If you flip it in the second choice, it would just end up being 2/1 or 2, which is rational. If you take the square root and you square it, it's going to cancel to just 8, because it would be square root of 64 if you prefer to think of it that way. Or a lot of you probably just are used to canceling squares and square roots. And if you look at the other one, square root of 2 times square root of 8, that's square root of 16, which is 4. So it's like which one of these things is the least like the others? There's only one of them that has addition in it. So if you weren't even going to do any work on this question, maybe that would be the one to guess. But if you really have no clue, just always guess the same choice each time. 39. A line through the origin and 10, 4 is shown in the standard XY coordinate plane below. It's always going to say it that way. The acute angle between the line and the positive x-axis has measure theta. So all that's in the diagram. What is the value of tangent of theta? So we're going to look at this diagram, and we're going to turn it into just a triangle problem because it mentions that they want tangent of theta. You might remember, and if not, you've got to get these down because there's always a few on the test that tangent is opposite compared to adjacent. A lot of people just remember it as TOA. The other two are SOH and CAH. So you've probably seen that somewhere. They tell you that this point is 10, 4, and that's X and that's Y. So this is the 10. This is the 4. They were hoping you wouldn't think of that. So opposite over adjacent. Adjacent means next to. This was the hypotenuse, not that we needed it for this question. So it's 4 out of 10, which reduces to 2 out of 5, which is choice D. Last one for this video. The equation, absolute value, 2x minus 8 plus 3 equals 5, has two solutions. Those solutions are equal to the solutions to which of the following pairs of equations? And then it offers some choices. So the first thing I would want you to do is kind of just glance at those choices. And you notice that they don't do much work, but they do a little work. It looks like they all involve taking this 3 and subtracting it off. And if you subtract that 3 off, this side would equal 2. So I'm liking the choices where the equations are equal to 2's. G has both of them as 2's. K has both of them as 2's. J has a 2, but they're not both 2. So I'm really down to just G versus K. And if you look, I'll turn it sideways and get it closer. If you look, what is the difference between G and K? In G, the top equation matches the top equation of K. So really, you just care about the bottom equation. Negative 2x minus 8 is 2. Negative parentheses 2x minus 8 equals 2. If you were to distribute this negative, this would become a plus 8. And so these are definitely not the same. It's just a matter of which one is correct. Well, you hopefully have been taught absolute value, that you split into a positive version and a negative version. And really, I know that some of you were taught a shortcut, but really in the negative version, you change the absolute value bars to parentheses and put a negative in front of it. And so that matches K. A lot of you were taught to put the negative on the other side and just skip straight to there. And honestly, if you were taught that shortcut, I'm sorry, but it actually wasn't a shortcut on this problem. All right, so let me take that off. And that'll be bye for now on this one. That was through problem 40. So you might have felt like there was at best half and half there. Questions you could do versus questions you weren't sure how to do. Maybe a little under that, and that's okay because, you know, we're most of the way through the test. the last 20 or so. I will split into 2 videos, but there'd be very few of those questions that the average high school student is going to get right. Really, you would use the last few minutes to go look through and make sure that there weren't any that looked super easy. If there are, you try them. Otherwise, you're just making sure that you've answered every question on the test. Well, thanks for now.